Hi everyone, I'd like to welcome you to our presentation today around multi-cloud IoT, which is a follow-up presentation of the one we did last year, where we've shown MongoDB Atlas capabilities on the different cloud providers and how to combine Atlas with the cloud-native IoT components. But we identified a clear gap, which is to integrate and unify IoT data across all the three different major cloud providers. And this is where we are going to dig down into today. Who is we? It's me, I'm Christian. I'm leading a team of solution architects here in Central Europe, and I spent my last 2 years building out an IoT practice within MongoDB. I'm joined today with Arun from PeerIslands, which is a strategic partner of MongoDB, and he is a clear IoT veteran with more than 30 years of experience in building hardware and software solutions in this area. And I'm also joined by Vasant from MongoDB as well. He's a principal solution architect here. And before joining MongoDB, he spent 15 years building global IoT solutions. We are going to present today, of course, again, some motivations and key challenges in multi-cloud IoT projects. What are the particular needs? We are going to show how MongoDB differentiates and answers to these needs. And of course, we're going to provide you with an architecture overview for such solutions and dig down into a demonstration. And it's not just a demo today, you will also get all the artifacts that we show, all the automations in the GitHub repository, so you can get started right away without reading a ton of documentation first. So without further ado, I'd like to hand over to Arun, who is going to start with motivation and key challenges.
Thank you, Christian. Good day, everyone. According to a recent study conducted by Forrester, over 85% of the companies have moved on to multi-cloud environments. Latest forecast from global technology research and consulting services firm, International Data Corporation, 2021 is expected to be the year of multi-cloud, with a vast variety of enterprises deploying combination of on-premise, hybrid, private and public clouds. Many of the organizations worldwide have started implementation leveraging multiple of these as we speak. This creates an opportunity for IoT as it's a natural extension to their multi-cloud strategy. We have heard many reasons from our clients on why they look for multi-cloud implementations. There are several considerations for multi-cloud IoT development. Primary driver is the total cost of ownership. However, real-time feedback, optimized workload, geo-presence, application performance, and the need to unify data for data science and engineering are strong technical needs based on our interaction with several CIOs and CTOs of global firms. In addition, enterprises have to carefully consider and meet the regulatory and compliance auditing needs that are both global and country-specific in nature to drive selection process. Take the current pandemic situation we are in today. It surpasses spiritual, conceptual, provincial, social, and teaching boundaries. IoT-enabled healthcare system is useful for proper monitoring of these patients by employing the interconnect networks of sensors, edge, and the cloud. The technology helps to increase patient satisfaction and reduces readmission rates. Patients can know their status. The providers can actually see what's happening with their patients. This has created immense opportunity for IoT. IoT multi-cloud covers several services and technologies in addition to what I mentioned. AML is one of them, and what we covered in last year, the digital twin technology. Markedly, we're also seeing changes in the business ecosystem, creating data as a service, where the device providers are now starting to become device clouds themselves. In all of the above, we talked about typical enterprise that are building an IoT solution. Take, for example, two firms that merged through an M&A activity. Now, they each may have developed solutions on different cloud platforms. These need to be brought together. Multi-cloud is here, and we are ready to scale them using MongoDB. While uptake of multi-cloud architecture has started to gain momentum, not all businesses are sufficiently prepared to implement their roadmaps due to several challenges. We broadly combine them into 4 vectors. The first one is the development complexity itself. Mastery in IoT requires knowledge in various areas that are complex endeavors. Sensors, edge, networking, interconnectivity, and the cloud all have different technologies, and expertise in each one of them have to be built. Based on 2020 IDC Meta CIO survey, I quote, about 30% highlighted migration as a key challenge. At the same time, about 40% cited the lack of skills as an obstacle hindering the rollout of multi-cloud strategies. If the strategy is to reduce less reliance on internal resources, personnel integration and complexity that comes along with it needs to be factored in as well. The second issue that enterprise have to tackle is the architecture modeling. Now, think back to when you have to deal with several of these integrations. In IoT, not only these several integration comes in, but there is a level higher than that of integration. Separation of operating workloads, including the data that comes at high speed, that has huge volume, and then have to be accounted for a variety of sources and data types. In addition, security plays into all of these, and above all, it needs to bring the value to the end customers. Ingestion pipeline, aggregation, processing of the immediate data, which we call it as hard data, short-term data, which we call it as warm data, and then long-term data, which is called cold data for data analytics, is another aspect that has to be considered. As an architect, we need to cater to the performance needs of the end user and the multiple persona and the complexity in the network. All of this had to take into account in defining the architecture, isn't it? So multi-cloud IoT architecture needs to consider such integrations. Architecture needs to address external and API integrations and workloads employed by the device data. The third challenge that the enterprise have to tackle is the total cost of ownership. Imagine yourself as the enterprise leader. Many of the IoT platforms have customized their IoT applications and pipelines. This is making it difficult to move across cloud platforms. For example, if you have developed IoT with AWS IoT, it's not easy to take that and move it to Azure IoT. So it may be also cost prohibitive to redo that work in an organization in an effort to move to one cloud platform. According to Forrester, 75% of the firms plan to either reevaluate, create a multi-cloud strategy by 2022 and 23 in anticipation of increased investment in the cloud. They also found firms are planning to increase the cost for the vendors, dollars, and the staff they need to devote to the cloud. TCO thus plays major in all these decision-making processes. The fourth one, but not the least, is the deployment architecture. We find these vary due to the level of DevOps and application modernization. You have Docker containerization, you have serverless architecture, you have components that comes in as PaaS services, and then you have to integrate from various resources and interfaces, which is coming through API management layers. Not only that, companies would have developed their own marketplace and they have service catalogs that have to be integrated. These will be impacted also by the level of automation and modernization. Now let's look at some IoT needs and use cases. While all of the above challenges for any of the multi-cloud aspect continue to evolve and pre-exist in some cases, a significant complexity comes from the data handling across the cloud instances and the central repository itself. IoT has created several innovations, as you all know, and it has created a lot of opportunities for the enterprises to extend their IT strategies and cloud synergies. We can't imagine a future that's not enabled by IoT anymore. From healthcare, which I just talked about, smart factories, energy management, retailers, smart facilities, and smart products, which even you use it at home, IoT is ubiquitous. Imagine sitting in New York and controlling the pressure valves in a smart facility in Austin. This has become today's day-to-day activity. IoT is able to help create this connected enterprise, remotely monitor and control and visualize it as well. And that is a drastic transformation from what we used to do as a closed concept of a constrained, siloed, suboptimal enterprise. One can now see from the list of use cases we have highlighted here, there is a common theme or a thread that are table stakes now. I'll talk about these in the next few slides. And this has become essentially the top IoT needs for any IoT solution. First one is the flexible integrations. This can be various edge, sensor, and network solutions. The second one we want to talk about is handling petabytes of scale data and very large speeds and high speed data from a variety of sources, image, text, binary, video, and so on. I just talked about remote monitoring and controlling these devices. The other aspect that need to be considered is able to manage these devices over the air through over the air software upgrades and so on. Enterprise integration via API, able to flexibly integrate with multiple feeds of information is critical. Device to cloud, unified data management is important. These are required, as I mentioned earlier, for AI, ML, and analytics, that the outcomes that they derive from each of these IoT use cases. Last but not the least, the built-in safety and security. Let us now look at a typical multi-cloud implementation in a corporation. Picture this, a global organization that have multiple cloud instantiation. One that is used for integrating the sensors, another that is doing workflow optimization, third that is used for enterprise data science and engineering aspects. Such an enterprise exists today. So for them, a market is moving towards an orchestration platform that can integrate these various cloud infrastructures. MongoDB provides seamless connectors for many of these when we talk about integrating multiple cloud instances. MongoDB's Atlas provides a unique proposition solution to integrate these disparate sources of information, and it can achieve this through globally scalable enterprise-wide solution offerings. I now invite Vasant to share MongoDB's unique technologies for multi-cloud in the next section.
Thanks, Arun, for summarizing the technical requirements and business needs of IoT platform. Now let's see how we can support these requirements using Atlas. If we consider any of the IoT use cases that Arun has mentioned, or just take an example of energy monitoring system where energy meters at edge sends telemetric or event data in a JSON format to the gateway. After the data reaches gateway, we need to capture, process, and persist the data efficiently. Here is where document data model of MongoDB adds a tremendous value to seamlessly ingest the data as is, as long as it is in a well-formatted JSON. If the platform has a transformation, then this transformed data via digital twin can be stored in a separate partition or a collection and can trigger functions to execute any business logic or rules. This makes the platform really simple and reduces the tech stack by removing many middleware data services, business engines or rule engines. With this, let us see the other key capabilities of Atlas platform. Using Atlas Web Console, customers can easily deploy, manage, and scale database clusters across GCP, AWS, and Azure. All this in just few clicks. With this, the platform can have a simplified management and monitoring experience of the federated data nodes spread across the clouds, all this under one hood. Multi-cloud clusters help IoT platform in many ways. Just mentioning few, customers have to no longer deal with the manual data replication and they can just focus on building the business behavior. With native option of data portability, platform can leverage best-in-class services across the different cloud providers. Sometimes IoT devices need to be deployed in various locations or regions. Okay, this might be one of the reason which triggers the IoT providers to choose multiple cloud providers, but they need a unified cluster behind it. So Atlas will be a great fit for this. Talking on building the multi-cloud data pipeline, now it is a lot easier to build a data lake, even though the customer's different context of data present in different cloud. Let's consider an example of smart city where traffic management system is in AWS and the parking solution is in GCP. Now by configuring one of the replication isolated node to be present in other cloud, customers can easily build a data lake for ML and AI by aggregating the data of traffic and parking, through which the use cases like dynamic pricing for parking or prediction of parking availability can be achieved based on the traffic density, where you are typically correlating the data of parking and traffic. Another important component of the platform is Realm, where you can build a serverless, fully consumable backend APIs on top of an Atlas cluster. On the other hand, Realm database solves many common mobile or edge headaches, like providing local storage for an offline first access, typically helpful when you have an inconsistent network, and a data synchronization between edge to the Atlas cluster and vice versa. First, for the same example of smart city, customer can easily develop multiple applications for different personas, like customer facing application to view and book the parking slot just by exposing any API on top of Atlas and integrating with the UI artifacts. Here, the effort you need to put is build an UI artifacts and integrate with the APIs. Also, you can build an edge controller or an application to automatically book a challan on violation of a traffic. All this with less code and using a serverless architecture. Coming to the data visualization, think about creating a reports or visualization for hourly trend of traffic or parking utilization or which zone has a more traffic violations. It's easy and quick to build these charts in just few clicks. You can also share or collaborate these charts to a different personas or even embed these charts in the custom applications. Deployment automation and diagnostic is another key requirement for any platform, and MongoDB provides it either natively or operators to achieve this. A number of extensions like K8s operator or Atlas operator or even the REST APIs provided by Atlas helps the customer to build the deployment on their own terms. We have also worked with the cloud providers to build and launch a serverless architecture for few platforms. For example, you can find a CloudFormation template which launches an IoT platform in a click. And which contains AWS IoT core, Kinesis components like Firehouse or data analytics, and the Atlas cluster. Anyhow, Arun will show a demo on this, and also he's going to share the GitHub links. Now let's spend a few minutes on the new key IoT features that's been added as part of 5.0. Important feature that first I want to touch is in support for time series. Before 5.0, customers used to implement the bucketing design pattern to store the time series data, where developers used to write a custom logic to aggregate the documents for a specific time range or for a fixed size of a document. This was done manually this was done earlier manually, right? To reduce the performance and to reduce the storage and memory utilization to a greater extent. With 5.0, you can achieve this natively. You don't need to build a custom logic for this. With time series collection, database clusters automatically organizes the time series data into a buckets while inserting. This allows the storage of data in a format which permits better compression and enables more efficient query processing. With clustered index in place, the data in collection is pre-sorted based on the index key. This allows the search key to map directly to the associated data rather than to a pointer. This adds a great value to a performance of query. Next is changes to the aggregation framework. MongoDB aggregation framework is loaded with a new data operations, which helps in building an analytics or querying data based on the data operations like date addition or date difference, etc. Another important addition is a Windows function. Prior to 5.0, the calculation of the Windows function was possible only via aggregation framework. So with the new enhancement done in 5.0, it gives a direct support for the Windows functions like calculating moving average or calculating the running count, etc. This simplifies the developer's effort. I want to touch upon another great feature that's an online archival and the data lake, which adds a great value to the IoT platform, though it is available before 5.0. This feature allows customers to auto-archive the database based on the rules or timestamp, and still gives the user flexibility to run the federated query on on active and as well as an archived source. This really helps to reduce the size of the active cluster and the cost. With this, now let me hand it over to Arun to show the reference architecture which embeds all these features and followed with a demo. Thank you all. Over to you, Arun.
Thank you, Vasant. We shall now look into the architectural construct for multi-cloud IoT implementation, which is based on the architecture that we introduced last year. I'll explain it briefly from left to right. On the left, we have devices and sensors and actuators. Based on use case, an edge gateway may be required to do the offline storage of data and local processing to allow for real-time processing. Some examples of that will be in the smart factories or connected vehicles where you have high data processing needs. The streaming and routing layer forwards data to the cloud using various protocols and standard. More about it in a minute here. The core is MongoDB Atlas as a multi-cloud data platform offering highly available, horizontally scalable storage of hard data. Optionally, analytic nodes provide an ETL-free mechanism to support analytic workloads, isolate from the operational workloads. All database clusters that can be distributed globally and spread across multiple cloud providers simultaneously. Vasant explained some of the new features that are coming in 5.0 that even helps to do real-time processing of IoT data, which are in time series. The online archive helps you in tiering the data automatically, and Data Lake provides access to large volumes of data in object stores. An integrated full text search engine is a powerful tool for building enterprise-grade, user-friendly applications. On the right, we see several applications from the mobile apps, microservices, analytics, and reporting as well. We'll talk a little bit about the Mongo charts, and the demo will actually show you the capabilities. Most of these applications can be spread across different cloud providers depending on the provider functionality. For the demo, we have built the standard IoT pipeline. This pipeline can be built seamlessly, and in the demo, we plan to show you the template used in the DevOps pipeline. MongoDB has recently been awarded GCP's Technology Partner of the Year. What does it mean? Atlas is available in Google Cloud Console as a fully managed service, and it can be deployed in many regions and allows for cluster level and VPC peering to any applications. High performance IOPS, enterprise grade security, and operational best practices are fully integrated and automated by default. Also, the billing is integrated into the cloud provider's monthly invoicing through the marketplace. There are many other integrations like Cloud Data Flow, Data Fusion, Kubernetes, App Engine, and TensorFlow, and others that are available with MongoDB. You can see that we have created the same with AWS here. We will be showing you the pre-built cloud formation templates in action in the demo today. It allows you to fully deploy these components of your choice and doing the data ingestion pipeline automatically with a stroke of a key. Similarly, the same can be built with Azure, and we have pre-built ARM template that you can try it out as an automation to enable you to run this. We have seen so far the reference architecture for the multi-cloud IoT solution with MongoDB. We present a quick demo of this automated pipeline, and we also pre-built these pipelines for multiple providers. The first demo is showing you the automation pipeline, and as part of this demo, we also will be showing you some aspects of MongoDB charts that are useful for providing and building a powerful IoT pipeline. Now on to the demo. The pipeline consists here of 4 templates: the master template, Mongo template, AWS template, and the networking template. One can create the multiple pipelines with the same master. Next, we configure the registry. So MongoDB allows you to do this privately. In step 1, we create a stack, and we upload the stack with the master stack. We can give a name to it, and we can upload these YAML files that we have provided you. And once it is done, the stacks are loaded, and you can see the parameters of those loaded stack easily. Like, for example, the automated inputs for the Mongo clusters as well. Once you acknowledge the CloudFormation IAM roles, the stack is up and running now. Once it's run, you will see that all the subsequent stacks are created. The master stack, as well as AWS stack, Mongo stack, it's all created automatically, and it will be deployed. And you can see that all the components that are relevant for this particular deployment is also loaded by default. You can then configure these templates to do certain actions. For this example, we have configured the connection between the kinesis and the Lambda function so that it can trigger the creation of the cluster. Next, we'll look into the Mongo cluster creation itself, and that will be part of the demo where we are automatically creating the cluster. And you can see that the cluster is now created and it's ready to go, and you can launch it in Atlas. It is connected through the ARM role, and you have actually able to connect it also through VPC peering. Once it is done, your entire system is up and running. Now we'll see some use cases in action. We have two use cases, intelligent transportation as well as the windmill. The first one I want to show you is the toll data, which is collected across the different toll points. And you can see that the time series nature of it is already folded as a bucket pattern here. In 5.0, it's automatically done. And with a few clicks, you can actually build your Mongo charts very quickly. And in this particular case, this entire charts were built within 20 minutes. You can see the different aspects of the application. You can see the traffic density, errors, and all of that in one place. The second one we want to show you is the windmill creation. So you can see that we have built massively global levels of scale here with the different countries coming into play and all these assets that are part of different enterprise. And now you can also go all the way deeper into the individual sensors and see the entire pipelines of sensors. With that, we come to the end of the presentation. Let's recap what we learned today. We learned about the key motivations and technology challenges for multi-cloud IoT, described how MongoDB differentiators help in building multi-cloud IoT solutions. We provided you with the reference architecture for building these solutions and a demonstration of an automated deployment and a quick start template. We invite you to get started today. Sign up for a free tier in Atlas and play with the reference architecture and try out these templates. And of course, we're happy to receive your feedback. Thank you very much.